Hello, this is the Level 1 Tai Chi Introduction to the Body. We're going to begin with the natural human body. And the natural human body is designed as the universal species. In other words, humans are so adaptable that they can live in any environment. They're pretty much a generalist species. And no one understood this better than Leonardo da Vinci. Leonardo da Vinci was the first medical illustrator. He meticulously and empirically watched how the human body worked, how animals worked, and he dissected these human bodies from a morgue and understood and put together these drawings that show exactly how the body worked. But he went beyond that. He went and he discovered the interconnectedness of it. Leonardo was also an engineer, so he knew how levers worked. But when he looked at an arm was working in an entirely different fashion. Now, Leonardo didn't have to go very far to see how humans worked and how the body was designed to work. He merely had to look outside his own window, because all around him were people working in primitive ways. They were designing scaffolding and other sorts of items, but the majority of the people were walking, carrying heavy loads on their backs and on their heads. And it actually is quite remarkable when we look at it from a modern perspective. And the reason is that we have been conditioned to not follow our bodies. We have been conditioned to follow the ideas of aristocratic physicians of how the body should work, more from trends and fashion than any kind of real science. And this became especially a problem during the Industrial Revolution, because it was much easier to compare a body to a machine than it was to understand how it could work on its own. There was just no physiological understanding of cells, of tendons, of pretty much anything. They were just kind of hunks of meat. And because of that, ideas were created that were just wrong. And those ideas permeate today. When we watch a Western man walking down the street, we can see that they waddle. They waddle from side to side. In fact, this is very easy. Just look at as you're going down the street while you're driving and watch people waddling from side to side. And the problem with this is their forces then just kind of shift, wearing out the joints. So on a flat surface, a person's wearing out their hip joints, and on stairs, these waddles destroy the knees with torsional twisting. And this wasn't always the case. Indigenous people walk differently, and we'll cover that further into the classes. And in their walk, they generate energy, and they walk in a straight line. So we're going to begin today to learn to experience our body differently. How to relax it, how to move, how it works, and how it doesn't work. And we're going to start with the basic elements of the cell. Now, human cells are really misunderstood. And that's not, a particular problem, but it's a matter of optics. When I first was in high school, we started to learn about cells, and they were amorphic blobs held together with surface tension. There's not much to them. But as the optics improved, we found that cells were complicated factories, and they had structures within structures. And their purpose was to produce product for use by the body. Now, the product could be action, like in a muscle cell. It could be energy, like in a nerve cell. Or it could be chemicals, like hormones. It could be mechanical, holding things together. Or any combination of mixture. And communication was always believed to be through chemical molecules passing back and forth from cells, because this was visible. So it was only natural. And when the chemicals passed from cell to cell, there was a change. So we thought that this was communication. But as time went on, we found out that this was actually delivery of the requested product. And that happened about 1995, when an intrepid scientist from Harvard discovered, hey, cells are talking. They're communicating through motion and pressure. And it was called transcellular mechanics or something. What we found out is that that was really happening, and the whole world of how biology worked changed by the change of the century. Now, the fixed cells form the structures and organ systems of the body. We're all pretty much familiar. And the moving cells, like white blood cells, T cells, etc., they provide, on the red blood cells, they provide services and protection for the body. But all of these cells aren't working alone. And that was one of the errors of our thinking. You see, all cells are connected to an extracellular matrix. This ghost heart, as we call it, is literally the structure of connective tissue of a human heart. And if you look closely, you'll see the details of muscle fibers, of nerves, of arteries, vessels, valves, everything that we know of as the physical heart is done in a scaffolding system of connective tissue. Now, that in itself is kind of amazing. But what gets more amazing is, how do you make a heart? You see, when you take that ghost heart and you add a little electrical conductivity to it, just a small amount, and put it in a womb-like environment and wash it with human stem cells, these cells start to differentiate. In other words, the cells that land on a nerve become the nerve. The cells that land on a muscle become a muscle. An artery creates an artery. So the scaffolding determines how stem cells differentiate. So our tissues are more of who we are than our cells, because our cells simply attach to the tissues and do the job at hand. And that job, as I have already said, is pretty much creating product, but more importantly, creating energy. So if we look at these anemones, we start to see that they just are attached to a piece of coral, like a scaffolding. and they float freely with the water movements. And within them, these clownfish go in and out, and they are almost like molecules. And what are they doing in there? Well, that's actually they're eating, they're protecting themselves, but they're taking away waste product from the anemones. And that is exactly how our body works. Our cells are in motion. And that motion is the state of relaxation. And that's a hard concept to grasp because we like to look at our cells as a concrete wall. It's not the case. When you get down small enough, there's a lot of space between them, and that space continues to grow. So cells float in this fluid environment, and that allows for the free flowing of nutrients, waste, and chemical products. And if you get crunched down, you can't move. And why is this an important point? Well, the cells interact with the scaffolding, and that scaffolding creates energy because it is piezoelectric. And that energy creates communication. So relaxed cells move in a fluid environment and they produce energy within the scaffolding around them. Why is this important? Well, it's communication. We talked about a delivery system of chemicals moving from somewhere to somewhere. But what's the ordering system? Well, that's based on a radical concept that cells actually talk to each other. And they do that locally and they do that globally because the cells are connected to the extracellular matrix. And they're connected by these little knots that we call ligands, but more importantly, by these integrins. Now, integrins are antennae, they're protein antennas. And as you can see in that second picture up there, is these antennae go all the way into the cell nucleus. And each one is paired with a chromosome. Well, actually, a chromosome will have a number of these. And what that chromosome is looking for is messages to produce RNA formulas to create product. So here we have all these little integrins, and they are anchored into the connective tissue, and they are listening for voices. And that's right. Cells talk in a very distinct language. And this language has been recorded since 2002. And not only do they talk in a language, but they talk in their own unique language. There are different voices for cancer cells than there are for normal cells. So, since 2004, it's been able to identify cancers by the sound of their voices. And that was done in primarily prostate cancers. So here we have cells who talk, and they talk by manipulating their cell body, which is like a very large diaphragm, and as that is manipulated, it produces acoustical sound waves through the interstitial fluids. It also creates energetic patterns through the integrins that vibrate the connective tissue of the extracellular matrix, which means that any particular cell can send a message to any other cell throughout any part of the body. That's pretty amazing. So that is the ordering system, and it's very unique. A cell could literally ask for a special formula of insulin, which makes pharmaceutical companies just crazy because they can't be that specific. So what messes this process up is a thing called bracing. When cells are stressed, they stiffen and they brace for impact. They literally get smaller, kind of like a boxer. They're protecting themselves from having any place to be penetrated. Now, what makes them do this are stressors. And stressors are chemicals that could be in the body. They are friction, mechanical frictions. They are fatigue. There are many different processes that cause stress for the cells. And when cells are faced, the most common with a chemical, they duck and cover. They block. They make themselves really stiff. And they get really close to that scaffolding, kind of like hiding into the scaffolding. And what then happens is they stay there until the threat is gone. But in this process of protective bracing, the cells do not have a mechanism to release themselves from this braced position. So they continue to stay there until an acoustical pattern comes in, a wave of sound, that pops them free, or motion, physical motion comes through that pops them free. But one must always remember, it's a choice. The cell can brace, it cannot release. If those acoustic waves are happening or those movements are happening, but the cell still perceives a threat, it will not unbrace. And what happens then is they get glued into position. You see, connective tissue is what humans make glue out of. Sinew, as we would call it. And this connective tissue is very sticky, and it gets stickier as you get older. It gets stickier with more sugar that you eat. And the stickier it is, the more it's going to stick together. Now, why is this a problem? Well, when a cell sticks to the connective tissue, it can't function, and it dies. And unfortunately, when it dies, it creates a scar. And that scar immobilizes the extracellular matrix there, so no communication can occur. And if no communication can occur, a cell can't reproduce into that space. So cellular adhesions start to become a place that immobilizes an organ. And in this process, the more stress you have and the more cells that die in that region, the less cells you have to do the task. And this creates an idiopathic disease. Now, genetic disease would happen when a cell is just about ready to die, when it's stuck to the connective tissue and it's just about ready to die, and it turns on a genetic code, like cancer. Now that sounds far-fetched, but in 2005, the National Institute of Health, after doing years and years of research, determined that all cancers, that's all cancers, are caused by cellular adhesions. In fact, we've got to the point now where they're actually caused by adhesions within the cell itself. The stress within a cell that creates adhesion patterns, which also can turn on the immortality factor of cancer or any other gene-expressed illness. So cellular adhesions cause all idiopathic and all genetic diseases. And that's where we begin, because that's what happens when the body goes wrong. Fortunately, the human system has many self-repairs. And one of the easiest things that we can do is utilize motion to change the cellular environment. And the thing that we find in nature are called wiggles. All animals wiggle. They wiggle many times as they move. They shake it out time and time after. Because our thoughts can't undo the knots of brace muscles and the energy that they suppress. And our muscles oftentimes can't undo themselves because they're traumatized and glued together. So muscle tone is a process of having massive amounts of tissue that are braced and glued together. And that's why the muscle never relaxes. In our culture, we say, whoa, look at the arms on that person. But they're down to about 40% functionality because half the muscle isn't working because it's all glued together. And what does that do to the joints? It wears them out. So adhesions are easy to see on the external part of the body. They mechanically destroy you and your functionality. Now, a good place to see this is Gil Hedley, and you can find this on YouTube, filmed a little movie called The Fuzz Speech. And he shows, using cadavers, how the glue joints literally lock fibers together. All those little bumps and things that you feel in your muscles are all glue joints. Now, wiggles are the natural way to unwind these knots mechanically and energetically. By rotating on an axis, like this dog is doing in the photograph, okay, he is creating waveforms within waveforms, and he's unwinding from this side-to-side motion the knots within him. You see, you don't pull on a knot. You wiggle the knot. When a knot's too tight, you keep wiggling the rope till it loosens up, till the fibers loosen up, till the fibers loosen up within the knot itself to release the friction. That is what we are doing when we're wiggling the body. Now, wiggles twist the connective tissue, unwinding the fibers and melting the adhesions to produce energy. You see, connective tissue is piezoelectric. When you twist it, it creates an electrical charge. So by merely twisting back and forth, you're creating an electrical charge that is designed to melt the glue joints. Connective tissue produces what we call physical chi every time it moves. So we're going to move forward and we're going to look at a exercise process that we do here at the White Willow School that we call the wiggles. And this is our stretching process. This is the way we stretch. We don't pull on muscles. We don't pull on the knots. We unwind the knots. So after doing these exercises, you start to notice things moving and vibrating that weren't moving before. But there's another little problem that we don't address in our society, and that is that our ergonomics create disease. So I want you to imagine, very simply, how it is to lean forward over your computer. And as you lean forward over your computer, you can feel your chest compressing. You can feel your shoulders moving down. You can feel that pain at the base of your neck. Well, the more hours that you do this, the more you are gluing tissues together. Very often I see people who cannot put their shoulders back. They have a permanent divot that keeps their arms rotated forward. And that means their chest muscles are glued. Their shoulders are glued into that position. Well, what does that mean? That means their lungs are glued into that position, that their lymph nodes are glued into that position. You see, if you lay on your side of the bed sleeping for 8 hours, your lungs are resting on your side, and they glue themselves together. And your heart gets glued together, and your brain gets glued together. And all these eventually kill the cells within and create idiopathic diseases. Heart disease, vascular disease, fibromyalgia, Alzheimer's, Parkinson's. Ergonomics kills you. But if you get up and you do your wiggles, that unwinds the adhesions. And eventually, the more you do it, the more deeper the benefit goes. Now, the first person to make this connection that stress causes disease was a guy named Dr. Edmund Jacobson. And he started his research in 1919. And he created mind-body medicine. And he didn't do this at a silly little place. He did it at Harvard University. And mind-body medicine was related, and stress was obviously causing disease. But we know just from what I told you of how that's done. It's not the thoughts that you have that create it. It's the patterns that maybe your thoughts are making. It's not the sleeping on your side that kills you. It's the not letting it go and getting the body back to basis. It's accumulated insidiously over time. So Jacobson discovered that all diseases were created by stress. And he observed the bracing of the skeletal physical muscles, just like I told you. Your shoulders get stuck in a particular place, and it starts to glue everything inside you together. But that's something Jacobson couldn't see. But he knew if the body was shaped in that particular position and could not change, that it affected the functionality of the organs within. That's just simple common sense. So what he did is he decided to create a system called progressive muscular relaxation. He knew he had to recreate space within the tissues, within the organs, to heal the body. Now, his relaxation progress was very simple. He would have people stiffen their muscles and then relax them. And we call this autogenic relaxation, because if you squeeze your hand, you can do that, and then let it go, you can feel the difference between the two states. In fact, what you're actually doing when you're squeezing the hands is you're creating a wave of buzz. because when you open it up, you can feel that tingling. So we've started the process. We've broken the inertia of the cells. We've set up a wave. If we do that quickly a few times, now we're creating some relaxation. But it's still not as effective as if we take that hand and wiggle it a little from side to side. Now we're not causing any pain, not causing any stress, and when we let it go, we can feel a softness that didn't exist from when we squeezed our hands together. So as a person would go through their body from feet to head or head to toe, they would get into a profound state of relaxation. And that state of relaxation would often induce altered states of reality, like out-of-body experiences or paranormal experiences. So in our system, we use progressive relaxation extensively because, like I just said, not only does it heal your body, but it also improves your perception of the reality that you exist within, and perhaps realities that are beyond what you can see. So let's review. Progressive relaxation is the natural state of cells and tissues in their unobstructed buoyant motion. We want to reestablish space to have our cells once again floating. Stress braces and glues the cells, tissues, muscles, organs, and nerves into immovable sections. Motion releases bracing and creates the piezoelectric energy, the buzz as I like to call it, that's necessary to unmelt the adhesive glue joints. And then the first step of relaxation is to initiate gentle motion to overcome the inertia and to initiate the process of producing energy. Now at first your motions are going to be pretty active, you're going to overdo them. But with practice, it's going to take just a gentle wiggle, just a gentle movement to create energy. Eventually, you will be able to produce more energy than you use now. So the steps to relaxing a muscle group is gently move or wiggle the body sections. Feel those cells and tissues releasing tension. And as they release, feel them expand and relax. And as they relax, feel for the buzz. Then begin to circulate a wave of energy. Next, what we'll do is we'll have you move on to your level 1 meditation 1 video. And I will go over on that video a little bit more about relaxation and then give you a 20-minute progressive relaxation to help you experience the relaxation of really being alive. Thank you.